Have you ever looked up at the night sky and wondered where it all came from? Not just the stars, but everything, us, our world, this beautiful blue marble we call home. How did it begin? To answer that, we have to travel back in time, way back, before there were cities, before there were dinosaurs, before there was even an Earth. We must journey back some 4.6 billion years, to a time when our solar system was just a dream, a whisper in the vast, dark emptiness of space. It's a story of cosmic violence and delicate creation, a story written in the stars themselves. Our story begins not with a bang, but with a cloud. Imagine a vast, swirling cloud of gas and dust, many light years across. This is a stellar nursery, a nebula, hydrogen, helium, tiny specks of dust. This is cosmic dust, the leftover ashes of long-dead stars. For billions of years before our sun was born, countless generations of stars lived and died, forging heavier elements in their fiery hearts, and flinging them back out into space. Our story, the story of Earth, begins with this stardust. We are, quite literally, made of stars. This giant cloud held all the ingredients needed to build not just a star, plan. And maybe even you and me. This colossal cloud floated peacefully for eons, a quiet giant in the Milky Way galaxy. But the universe is never truly still. Somewhere, far away, a massive star reached the end of its life. It exploded in a spectacular supernova, a final brilliant burst of light and energy. This explosion sent a powerful shockwave racing through space, like a ripple in a cosmic pond. When this shockwave slammed into our quiet cloud of gas and dust, it gave it a nudge, a gentle push that would set in motion a chain of events so profound it would lead to the creation of our world. The cloud, once stable and diffuse, began to collapse under its own gravity. The collapse was not sudden. It was a slow, graceful fall inward that took millions of years. As the cloud contracted, it began to spin, faster and faster, just like an ice skater pulling their arms in to spin more quickly. The material gathered toward the center, becoming hotter and denser with every passing moment. Most of the gas and dust, over 99%, was pulled into this growing central core. A new star was about to be born. This star would become our sun, the anchor of our solar system. As our young sun ignited at the center of the spinning cloud, a vast disk of leftover gas and dust swirled around it. This was the protoplanetary disk, a cosmic construction site. Think of it as a flat, spinning pancake of material, with the hot, bright sun at its center. Close to the sun, it was incredibly hot. Rock, metal. Further out, beyond the frost line, lighter materials could freeze: water, ammonia, methane. This temperature difference was crucial. In the hot inner region, tiny grains of rock and flecks of metal. In the cold outer regions, rock, metal, and a huge amount of ice. Mercury, Venus, Earth, Mars, small and rocky, Jupiter, Saturn, Uranus, Neptune, giant worlds made mostly of gas and ice. The recipe for each planet was determined by its location in this massive spinning disk of stardust. The next step is to get tiny particles to stick together. Pebbles, rocks, boulders, mountain-sized bodies. Planetesimals dominated, colliding in a cosmic demolition derby. Messy, but gravity always wins. In the inner part of the solar system, about 93 million miles from the new sun, one of these growing planetesimals was on its way to becoming our home. We call this Proto-Earth. Its gravity grew stronger with every collision, pulling in more nearby planetesimals. Each impact was an explosive event, releasing tremendous energy. This energy, plus heat from radioactive decay, caused the entire planet to melt. Our world began as a glowing, molten ball of lava. This molten state allowed differentiation. Heavier materials, iron, nickel, sank to form Earth's dense metallic core. Lighter silicate rocks floated up, eventually cooling to form the mantle and crust. Earth has layers, like an onion, a solid inner core, a liquid outer core, a churning mantle, and a thin, brittle crust. The liquid iron core creates Earth's magnetic field, forming a protective magnetosphere. Without it, the solar wind would have stripped our atmosphere long ago, leaving a barren world like Mars. About 4.5 billion years ago, accretion slowed. proto-Earth swept its orbit mostly clean. Imagine for a moment, the young Earth. It's nothing like the world we know today. The surface is a global ocean of magma. No solid ground, no water to drink, no air to breathe, a thick choking shroud of hot gases and vaporized rock, asteroids and comets slammed into the lava ocean. This period is called the Hadean Eon, named for the Greek god of the underworld. Volcanoes were everywhere, vast fissures spewing lava and toxic gas. Carbon dioxide, water vapor, nitrogen, sulfur compounds, unbreathable and crushing, a thin black crust formed only to be shattered by impacts or torn by mantle currents. A terrifying, inhospitable landscape, yet the seeds of our world were sown. Volcanic outgassing built atmosphere, comets delivered water, core heat drove mantle convection, the engine for continents. Earth had to undergo this fiery baptism to become the planet we know. Our planet has a companion, the Moon. But where did it come from? About 50 million years after Earth formed, it was not alone. A rogue Mars-sized world, Theia, was on a collision course. The collision was a glancing blow, unbelievably powerful. It vaporized Theia and much of Earth's mantle, blasting a ring of molten debris into space. Gravity acted on that cloud. Within a few hundred years, material clumped together, coalescing into one large body, our Moon, once 15 times closer than today. A glowing magma ocean world, raising colossal tides of molten rock on Earth and Moon. This explains the Moon's large size, mantle-like rock, and tiny iron core. Most of Theia's dense core merged with Earth's core. Since then the Moon has drifted away, stabilizing Earth's wobble, creating our tides and lighting our nights. After the chaotic birth of the Moon, the Earth was once again a molten ball, but the great bombardment was slowing. The planet could finally begin to cool. Volcanoes pumped out gases, including a huge amount of water vapor, the air thick with steam. As the surface cooled below 212 Fahrenheit, 100 Celsius, the vapor began to condense. It began to rain, not a gentle shower, a torrential planet-wide deluge for thousands, even millions of years. Water ran over new rock, collecting in vast basins and craters. Slowly, drop by drop, the first oceans began to form. Some water came from volcanic steam. Much was delivered by comets and asteroids, cosmic water trucks. The water in our oceans, the water we drink, may have once been part of a distant comet. At first the oceans were hot, acidic, and brownish-green with dissolved iron. A water world dotted with volcanic islands. Water is a universal solvent, a perfect medium for chemistry. Earth was becoming a laboratory, a cradle for life. With the great rain over, Earth was a blue planet, a world of water and volcanic rock. The air was thick with carbon dioxide and almost no free oxygen. A strong greenhouse warmed the planet, roughly balancing a fainter young sun. Days were perhaps 6 hours long. The giant Moon drove massive tides across shallow seas. Earth cooled, lighter, granite-rich continental crust began to form, floating like foam on a latte. Microcontinents drifted on mantle currents, the beginning of plate tectonics. They collided and merged, pushing up mountains. Rain weathered rock, washing minerals and nutrients into the oceans, changing their chemistry. On the ocean floor, hydrothermal vents spewed hot, mineral-rich water, perhaps perfect for life's first sparks. The bombardment ceased. The surface stabilized. Earth's rotation slowed, days lengthened, and the Moon drifted away. A stable crust, vast oceans, a dynamic atmosphere, the stage was set for life to begin its journey. And so, our journey through time comes to a close. We started in a vast, cold cloud of stardust. We saw it collapse to form our sun and a swirling disk. Tiny grains stuck together, growing through violent collisions into a planet. That planet melted, separated into core, mantle, and crust. A cataclysm tore a piece away to create the Moon. Then the rains fell, and the first oceans formed. Our oceans, our continents, our atmosphere, our Moon, our magnetic field, our water, our bodies, born of stars. The ground beneath your feet is recycled stars. The water you drink may have crossed the solar system. The Moon was born from unimaginable impact, a pale blue dot as Carl Sagan called it. Remember the journey those atoms have taken to get here. We are a part of the universe, a way for the cosmos to know itself. Our exploration is far from over. There is still so much left to wonder about.